All right, they've got to start off. There's a sleeping Ava. There's a sleeping Murphy. Okay. So what happens if we have to combine these motions? All right, so we always begin by identifying our base function or having an idea what our base function looks like. In this instance, we have our base function being the square root of x. So if I drew the square root of x, it would start at 0, 0 because 0 as the x value has a square root of 0 as the y value. And 1, 1, here's 1, 1. 1 plugged into the square root of x is 1. And 4 gets me to 2. Now, let's just make a couple of adjustments. And the question I'm asking is, what does 2 and 4 do to this base function, or in this case? Well, I'm going to take g of x, and I'm going to think about it as 2 times the square root of x plus 4. What are these things doing? Well, our base function is the square root of x. We're multiplying it by 2, so it's a vertical stretch of 2. And this positive 4 is a vertical shift up. So if you look, this has moved up 4 units. The 0, 0 has moved up 4 units. Now that's 0 is typically not where the stretch gets shown, but this does. So it used to be 1, 1, so there was this climb of 1. Well, now over here we're at 1, 6. So there's this climb of 2 rather than a climb of 1. That's what that 2 is doing here. It's almost like a slope idea, okay? Now, what happens if we think about, and again, we're asking about the 2 and the 4. What if our g of x is the square root of x plus 2 minus 4? Well, the positive 2 is being added to the argument, and it's inside the base function, so it's a horizontal shift, and it'll be 2 units to the left. And the negative 4 is a vertical shift 2 units down. Okay, again, vertical shift, the sign is the direction of the movement. Horizontal shift, it's the opposite of. Okay? Your book likes to, and in fact this is very common, they talk about even and odd functions. Now we did a little bit with evens, and we did a little bit with, we didn't do anything with odds, forgive me, but one of the keys to having an even function is that it needs its lead exponent to be even. So it's got to be a 2 or a 4 or 6. And for an odd function, its lead exponent needs to be odd, you know, to the 3rd power, the 5th power, etc. Now, in order for something to be an even function, the test that you run is, just forgive me for a sec, the way you're running the test is, does f of x equal f of negative x? Does that squaring take care of that negative? And so if I let f of x be 2x squared plus 4, I take and I plug in negative x in place of x, and I get 2 times negative x squared plus 4. Well, that becomes positive x squared, because when you square negative x squared, it becomes positive x squared. And this function is exactly the same, and it must be exactly the same. Number for number, sign for sign, variable for variable, exponent for exponent. And since they're exactly the same, it's even. Okay. Over here, for odd, there's 2 ways to do it, and I do it a little bit weird. Okay, so most books will say f of x is equal to negative f of negative x, but there's an alternate way to deal with this, and I tend to prefer my way. It's easier to explain. It may not be as smooth to you guys, so if you're comfortable with how the book does it, again, happy to let you do it, totally comfortable with it. But that negative, you can divide both sides by negative 1, and so you get negative f of x is equal to f of negative x. So if we start with f of x is equal to 3x cubed, so that's our function, and I'm going to deal with negative f of x. I'm going to deal with this part right here. Well, that's just putting a negative in front. And if there's terms, you'd have to distribute it, but this is just one term, so it's negative 3x cubed. Now let's compare, or look at the right side, and then we'll compare the two. So f of negative x. So in place of the x, I put negative x. And because it's to the 3rd power, it's negative x times negative x times negative x. And so what I get is a negative x cubed. And these two are exactly the same. And so this function is odd. Okay. Couple of examples. Number 12 out of the book. It says y is equal to f of x plus 3. Now, our base function we don't know, and you should really always kind of ask that question, what is the base function that we're dealing with? Well, we don't need to know what the base function is. We can tell from the location of the 3 that it's in the argument. And so this is a horizontal shift 3 units to the left. This is a positive 3, it's moving to the left. And if you ever forget, just realize that the origin is the easiest spot to figure out what happens to that function. And so what you do is you subtract 3 on both, and you find out that it moves it to the negative 3. Okay. Number 20. All right. So we have 4 times the quantity x plus 1 squared minus 5. Our base function is the x squared function. If I drew the x squared function, it would look something like that. Okay? Now, what is the 4? Well, the 4 is being multiplied by the argument. Multiplied by the function, the squared. And so it's a vertical stretch. It's positive, so this thing's going to open up. This positive 1 is in the argument of the function, because the squared is the function. And it's plus 1, so it's going to move 1 to the left. And this negative 5 is moving it down 5 units. And we're really in what's referred to as vertex form, if you can remember your parabolas from past algebra classes. And you pull out this value as an opposite, so it's going to be negative, and you keep this as the same, so it's negative 5. So if we look at the vertex, it's negative 1, negative 5. We put our dot, go down and up. Now, the book asks, where is it decreasing and where is it increasing? Well, from negative infinity to 1, negative 1, forgive me, this is decreasing. And from 1 off to positive infinity, it's increasing. So our notation is negative infinity to negative 1, it's decreasing. And it's increasing from negative 1 to infinity. And I don't use the closed brackets. These are open brackets. Okay. Number 28, when we look at the absolute value of x minus 1 plus 4. Base function is the absolute value of x. If I do a quick sketch of that, it's going to look something like that. Well, this is to the negative 1, so it's 1 right, because it's in the function. The function is the absolute value function. This is 4 up because it's being added to the function. And it's positive, so it opens up. So this is shifted over 1 and up 4. Okay? All right. Hopefully that helps.